Clear skies, with some high clouds changing to rain late. Temperatures...
But representatives report that they have reached little agreement.
That's how they...
You heard that first here on WLUW, your energy radio station.
Energy!
Now for an energy quiz question. What weighs 5,000 trillion tons, is right in front of your face, but you can't even see it? With an answer to that and other questions, stay tuned. On the air with Saskia Young and Brian Bosak is next, so get ready.
Hi, I'm Brian Bosak.
And I'm Saskia Young. Welcome to another edition of On the Air, a call-in science show produced by students for students. You keep our phones ringing with your science questions and we try to give you the answers.
Interestingly enough, for a program called On the Air, today's show is on the air. That is, it's about the air, about the atmosphere. When you look at the Earth in one of those awesome pictures from space, it just seems to be hanging there all alone with nothing around it, except maybe some clouds.
But there is something around it, and those clouds are part of it. That something is a huge ocean of gases called the atmosphere. The atmosphere is held in place by our planet's gravity. Otherwise, it would drift into space.
While many planets have an atmosphere, it's what our atmosphere is made of and the things it does that lets life on Earth exist. Think of the atmosphere that surrounds our planet as being like the deep blue ocean is for fish. They're always passing through it. We, the creatures of the land and air, do the same thing. We're always passing through our ocean of air, our atmosphere.
When we think of the sky, we tend to look up. But the sky actually begins at the Earth. It starts at ground level. We stand, walk, and move through the sky.
Of course, except for clouds, the atmosphere is invisible. No matter how hard you look for it, you can't see it. In fact, unless the wind is blowing, you can't feel it. But even if you can't see it or feel it, it's there.
So let's get to the phones. Remember, just dial 491 for air. While we're waiting for the phones, let's cover a few of the basics. There are some elements in the atmosphere that we couldn't live without. Oxygen, for one thing. Without oxygen, humans and lots of other animals couldn't exist. You might be able to live without food for about a month, or without water for a few days. But you can only live a few minutes without oxygen. And don't forget some of the other gases. Carbon dioxide and nitrogen are important for plants to grow. And plants are the source of the oxygen we need.
And without the atmosphere, there would be no sound at all. Because sound is the vibration of air particles. If there was no air, there would be no sound.
Well, fortunately, our listeners can hear our sounds. The atmosphere is made up of several layers.
It might be easier to think of it as a skyscraper with a whole bunch of floors. Some floors have shops, and others have offices. And up top there's a fancy restaurant. And a place with a view. The atmosphere is sort of like that.
Scientists have split the atmosphere into layers that start at the ground level and move up towards space. Each layer has a different name, and like the companies on the different floors, each layer has a different purpose. The most common way of separating the atmosphere into layers is by temperature. We live at the bottom of the atmosphere, in the troposphere. The troposphere is warmest near the Earth's surface, but temperatures decrease with altitude to the top of the troposphere, where they may reach as low as minus 80 degrees Celsius. The troposphere goes up to about 10 kilometers. That's just a little higher than the top of the Earth's highest mountain.
Now that, my friend, is cold.
Between 10 and 50 kilometers in the stratosphere, things warm up, mostly because of the presence of a gas called ozone. Ozone heats the air in this layer by absorbing ultraviolet rays from the sun, and temperatures may get up to around 0 degrees Celsius.
That's more like it.
The stratosphere is where transcontinental jets fly, because there's almost no turbulence from weather systems. The mesosphere is next, and here temperatures begin to drop again. At its upper limit, about 90 kilometers, temperatures can hit minus 138 degrees Celsius, super cold. Trails of hot gases from meteors can be seen in this layer. The thermosphere begins where the mesosphere leaves off and goes up to about 500 kilometers. The sun may heat this part of the atmosphere to more than 1,000 degrees Celsius, super hot. The thermosphere largely corresponds to the ionosphere. Here, electrically charged molecules reflect radio waves back to Earth. Otherwise, they might escape into space and we'd never hear them. Way out there beyond the thermosphere is the exosphere. Here, molecules of air are so widely dispersed that there is no temperature that you could feel. The exosphere extends from about 500 kilometers up to where it gradually mixes with space.
Let's see. Troposphere, where we live. Then stratosphere, mesosphere, thermosphere, and exosphere, right?
Exactly. Now with that out of the way, let's go to the phones. Hi, you're on the air.
This is for Brian. What's the atmosphere made of?
Well, it's different from layer to layer. But in the troposphere, things are pretty steady. Yeah, it's a mixture of gases that's always the same. 78% nitrogen, 21% oxygen, and the rest, that last 1%, is trace gases, like carbon dioxide, hydrogen, argon, and some others. Oh, water vapor's there too. You can't forget water vapor. The atmosphere always has a certain amount of water in it, in a gaseous form called water vapor. Depending on its temperature, air can only hold so much water vapor. Additional vapor condenses into water droplets. Huge groups of droplets form clouds. In these clouds, the droplets collide to form larger droplets. When they become too big and heavy to be supported by the air, they fall to the ground as precipitation.
So clouds, rain, snow, fog, hail, and dew are all the result of water vapor and temperature change.
You got it.
You're on the air. What's the question?
Does weather happen throughout the atmosphere?
Weather happens primarily in the troposphere. In fact, tropo means change. The changes that are always taking place, that's weather. And now for more on the weather, let's go to our meteorologist, Tom Skilling.
Chicago's Energy Weather.
The atmosphere that surrounds our planet is in a state of perpetual motion. The complexity of this movement is evident when we string together satellite pictures in what we call satellite animations. Here we can see a giant storm bearing down on the Midwest and southern Canada, carrying its rains and snows through this region. Another weather system is seen moving onshore off the Pacific Ocean. The complexity of air movement is evident in cloud patterns, but boiled down to its simplest form, the prevailing winds that occur in our hemisphere do so in three basic bands. We have the cold polar easterlies that blow through northern North America, the very fast and powerful westerlies that occur halfway between the North Pole and the equator, and the warm tropical easterlies that carried the first explorers to this continent. Here, the vertical build of clouds associated with a giant storm is evident as we animate satellite imagery over a 24-hour period. Air motion on our planet takes place in two basic planes. The sideways or horizontal movement, with which we're all so familiar, is what we call wind. these occur between regions of varied temperature. The larger the temperature change, the stronger the wind. But just as prevalent and just as important are the vertical motions of air, which are less obvious to us. When air sinks over a continent on a broad scale, a giant dome of fair weather high pressure develops. High pressure days are generally nice days, with lots of blue skies, few clouds, and dry winds. On other regions on Earth, the air rising away from the planet cools, producing clouds and dropping pressures at the surface, making what we call a low pressure system. Low pressure days are often stormy days, with lots of clouds, wind, and precipitation. High above us, far more organized winds blow. The most predominant among these is the so-called jet stream wind that blows between 10 and 45,000 feet, or 4 and 15 kilometers above the Earth. These fast-moving winds carry storms, particularly during the autumn, winter, and spring, and form on the south edge of very cool air that seasonally expands southward. The jet stream, the winds on Earth, all driven by the energy of the sun.
Pilots also need to know about weather. Before every flight, pilots receive a formal weather briefing.
Good morning, Commander.
Good morning, Petty Officer Caravella. Planning a flight to Philadelphia. Can you tell me how the jet stream looks?
Well, sir, current polar front...
This includes any large air masses and systems and any turbulent weather cells.
Flight level 30,000 feet, you will pick up...
By flying the right direction in a jet stream, that's from west to east in the northern hemisphere, pilots can save lots and lots of fuel.
Is forecasting for 1,000-foot overcast, 2 miles...
Wind speeds near the center of these bands often reach 150 kilometers per hour.
Tops of 45,000 feet.
Okay, thank you very much.
You're welcome, sir.
Hi, what's up? You're on the air.
Can you guys tell me how come the sky is blue?
That's probably the #1 most asked question. It's a little hard to imagine, but 32 kilometers above Earth, the sky is black. At 29 kilometers high, light from the sun encounters densely packed air molecules. Most of that light continues to the surface, but air molecules are just the right size to scatter blue and violet light throughout the sky.
What about sunset?
Even harder to imagine, but just try to picture the sun sliding down past the horizon. Light coming from this very low angle has more air to travel through, so most of it is lost. Only the red, yellow, and orange light is left to reach our eyes.
How do you know this stuff?
It comes in handy on dates. After the sun sets, when there's no light, the sky is black so you can see stars. Then it becomes pretty...
Let's move on.
Hi, you're on the air. What can we do for you?
My brother wants to know this, but he's too scared to ask. Do meteoroids burn up in the atmosphere? He says they do. I say they burn up in space. Who's right?
Your brother is. Those meteoroids are solid bits of rock or metal that zoom into the Earth's atmosphere from space at anywhere between 54 and 300,000 kilometers per hour. Friction with the atmosphere usually burns them up, most of the time in the mesosphere.
A really humongous one hit the Arizona desert 20,000 years ago. It made a crater 175 meters deep and 1,300 meters across. Very few meteorites get through, unlike the moon, which has no atmosphere. Its surface is all pockmarked with craters from meteorites slamming into it. Okay, you're on the air. What's the question?
Hey, Saskia, this is Terry.
Hey, Terry.
I'd like to know if the atmosphere weighs anything, and if it does, how come we can't feel it? At least I can't.
First of all, the atmosphere weighs a lot, about 5,000 trillion tons. Lots of zeros.
Most of this weight is crammed into the troposphere. That's the layer that we live in. 75% of that is below the top of Mount Everest, which is about 8,000